Oh, hi. Fancy meeting you here at the Daily Space Weather Show. Just showing you the most comprehensive daily space weather content in the known universe, as well as the most detailed solar imagery you'll find anywhere here at the Smash News Network. Least busted name in news. No big deal. And by the way, no. The sun is still not going to kill you. That's the past 24 hours from SDO. One new active region there known as a sunspot rising over the northeastern limb. I guess that'll be the story. There's some CMEs happening as well, coronal mass ejections, where large amounts of matter come blasting out of the sun's atmosphere. There's 304 angstroms as well. And before we continue on, let's take a look at sunspots. That is the SDO continuum. December 11th and December 12th to date. Here is the SDO colorized magnetogram for the same time period. And by the way, if you enjoy the content, press the like button. Tell your friends and foes about us. Press share. Leave a comment. Tell your friends and foes about us. If you're mad, leave a comment about that too. We encourage all rage comments. We are free speech purists after all, which I guess is controversial in itself in the year 2023. Congratulations on realizing the channel exists. The following are paid endorsements. Smashomash.com/Smash Team is the first one. If you want subscription services and additional content, if you want to hear about boners in space, yeah, we covered it just earlier today. Smashomash.com/Smash Team. If you want to hear about it, guess what? Only Gold and Silver Smash Team members get that content. So, yeah, I mean, that's those are just some facts for you there, some facts. And let's move on to some more paid endorsements. Today's featured product from the merch store is, and by the way, there are massive savings at the merch store, the Croissant Earth Society. When will you stop believing NASA's lies and realize that the Earth is shaped like the French breakfast pastry? Not the oblate spheroid. What are you, crazy? What, do you believe NASA's lies? Well, you don't know about Operation Paperclip? Of course Earth is shaped like a croissant. What are you, crazy? You think it's shaped like a sphere or a pizza crust or something? That's just crazy talk. When will you stop believing NASA's lies? When will you visit the links below this video in the description and find 40% savings site-wide on our merch? Do you want to ask a particle physicist a question? Well, we've got one lined up for you. The deadline is every Thursday morning whenever I wake up. That is when the deadline is. I submit the question by that point in time. If you want to submit a question to ask a particle physicist, join us over at smashomash.com/forum. In the General Science Forum, there is a thread for it. So if you'd like to ask a question, feel free. smashomash.com/forum. The next paid endorsement is Hemp Lucid. If you want to save 10% on your Hemp Lucid order, they make great gifts, by the way. Enter the promo code SMASHOMASH10. Yes, SMASHOMASH10. It'll save you as many percent on your Hemp Lucid order. SMASHOMASH10 on checkout is the promo code to save you as many percent. HempLucid.com, another paid affiliate. Another one is the Amazon shop, and today's featured product over there is the Smash-O Rage Pills. So Smash staff refers to these as Smash-O Rage Pills, and it's resveratrol, so it's a plant blend, and I won't tell you what's in them. You can visit amazon.com/shop/smashomash, amazon.com/shop/smashomash, or you can just click description, and right below this very video are links to all of that sort of stuff. Also links at smashomash.com, and welcome to the Neo Renaissance. There's the Amazon link right there on the home page. Smashomash.com, the official homepage of the Smash News Network, least busted name in news. And once again, congratulations on realizing the channel exists. Let's get into some more space weather stuff. But first, let's talk about volcanoes. These are what are currently erupting. Krakatoa producing a 4,000-foot ash plume. Semeru, 15,000-foot ash plume over East Java. Dakono producing an 8,000-foot ash plume. Ioba on Vanuatu exploding. 14,000-foot ash plume there at Aoba. Also, Popocatépetl exploding, flight level 210, 21,000-foot ash plume over central Mexico. Shout out to Mike Bordages. Sancha Guido also exploding, flight level 150. Fuego exploding, flight level 150. Nevado de Ruiz exploding, flight level 230. Sangay exploding, flight level 200. Revenador exploding, flight level 150. Sabancaya intermittent emissions there. And Ubinas is also exploding. It's a flight level 230 over Peru. Flight level 230 means a 23,000-foot plume of volcanic ash. Please do not pole vault the caldera. Here's seismic activity for the past 90 days. That is what has been going on. And let's get to the 24-hour earthquake report. Fresh from space. Here it is. These are the quakes of a 5 or greater magnitude. Philippines had a 5.0. South Sandwich Islands had a 5.1. Indonesia had a 5.0. Tonga had a 5.0, and that's the real site of major activity there for the past couple of days around Tonga. Philippines also seeing a 5.0 up there. Largest quake of the past 24 was a 5.8, I think, at Tonga. There was also a 5.7, perhaps a foreshock happening there at Tonga. Let's hope that's not the predecessor to a larger quake. Southwest Indian Ridge also had a 5.2. And what else do we have? Here's the thing. A 5.6 near Tonga. Papua New Guinea had a 5.0. Philippines had a 5.1. And that is the end of the quake list. Let's get back to our space coverage. So there is the past 24 hours from SDO 1700 plus 171 angstroms is what we're looking at here. And you may see some activity there in the southeastern limb. There was a coronal mass ejection there. Some plasma reorientation happening as well. Maybe even some filamentary collapse happening in the southeastern limb. Let's take a look at some additional information here. The 10.7 centimeter radio flux now down to 126 solar flux units. 126 is the new number for the radio flux. That is the past 1 year. There is a space weather enthusiast dashboard. No space weather storms forecasted, although we did have a little bit of geomagnetic unrest. We'll get to it here momentarily. First, the last 4 hours of Earth's magnetic moment from space. Space, a frontier. These are the voyages of the space weather modeling framework, which strives to create an active and accurate model of what's happening to about 12 Earth diameters. This particular space weather modeling framework product depicts magnetohydrodynamic pressure, the units of which are nanopascals. So those are the past 4 hours of Earth's magnetic moment from space. And we did see a brief period of geomagnetic unrest caused by a minor coronal mass ejection impact. Again, we will cover that here momentarily. Before we do that, we'll show the last 4 hours of Earth's magnetic moment from the ground as well. And here you have it. There are the past 4 hours of magnetic flux density at ground level. The units of this, nanotesla. It's depicting changes to Earth's B field, or geospace delta B. The B field being the field that goes through the magnet, this magnet being Earth. KP index currently at 2.33. Again, we did see brief geomagnetic unrest. KP 2.33 is the current planetary K index. And here are the solar winds as measured from the ACE and the Discover. There's the ACE. We're going to call out the Discover stats. The Discover stats there showing up a little bit higher density there at about 14.5 protons per cubic centimeter. Solar wind speed here 376 kilometers per second. So here was the main impact of the most recent CME right in here. You'll see the KP index coming up, changes to the magnetic field strength and orientation. Also some changes in the solar wind density and the solar wind velocity, all happening around the same time. Also an uptick in the solar wind plasma temperature. Again, current conditions about 12.5 protons per cubic centimeter for the density. Solar wind velocity here about 380 kilometers per second. Ghost magnetometers here remain smooth with a couple spiky little showings there. That is that brief period of geomagnetic unrest. And let's move on to the top view ecliptic plane field plot. So that's what's going on in the heliosphere. The top view ecliptic plane field plot. And what do we have? Anything new happening over there in the east? And indeed, a South Pole current sheet now rushing this way. So if you look over there on the east, which is this area right over here, you'll see that red region rushing in. That is the South Pole sector. So sector boundary crossing here, likely to arrive as early as midway, I'll say early in the day tomorrow. We may see the South Pole sector show up there. Here's our line of sight ecliptic plane field plot. And things are getting more and more complex as far as predictive value goes as the sun gets more and more chaotic as we approach solar maximum. So here's our line of sight field plot. And you see a lot of motion happening over there in the east. That is some magnetic indecision once again. So we're seeing very clear indications here that there is a bit of a magnetic tug of war going on again on the eastern limb. You get great indications of that via this data. So this is really the ultimate data in a lot of ways. Our line of sight field plot, and here's our line of sight coronal hole plot. And we've got South Pole oriented coronal holes here battling North Pole coronal holes. So eventually one of those is going to win out, and what's going to happen ultimately, folks, is you're going to get the North Pole magnetism down here and the South Pole magnetism up here. So keep in mind we are still not at solar maximum, at least not likely to be. And let's move to the SDO. There are coronal holes for the past 24 hours from Solar Dynamics Observatory. So we may have an extended period of sputtering high-speed coronal hole winds in the coming days. Still probably about 2 days out before we see any perturbations from that. But that is the past 24 hours, and let's move to sunspots. Yay, sunspots. They've come back over 100 at about 114, 113, something like that. That's the sunspot number from Rob, the Royal Observatory of Belgium. Next, moving on to our flare probability monitor and scoreboard. And we've got a lower likelihood of solar flares than we did at yesterday's daily space weather video. These sunspots are fairly magnetically simple. Let's take a look at those from SDO Continuum. There you go. Mostly stability here, and a minor uptick in the sunspot number as a result of those rising groups in the northeast. That sunspot will be known as 3518. Will be the name of this sunspot up here, 3518. And we'll show the magnetogram as well. We're showing all full disk imagery today, so no zooms, as it's been a quiet day on the closest star. Next, moving on to energetic particles and solar flares. And we ain't got none. Flares have been minor. Solar energetic particles have been non-existent for an extended period of time here. So there's the ghost proton flux. There is the X-ray flux, and we are seeing an uptick in the X-ray flux here. So that's interesting. Not sure if that's from the new sunspot or if it's from the group in the northwest, but in any case, little uptick there in the X-ray flux for the past about 6 hours. So let's take a look at X-rays here. Oh, and by the way, don't forget to ask a particle physicist a question. Here is 94 angstroms from SDO. Oh, it looks like another active region there rising in the southeast. So that's partially to blame for that. You can see a big brightening happening there in the southeast. So possible sunspot there somewhere nestled behind that limb. And let's move on to a star chart. Here is our star chart for Lehigh Valley, Pennsylvania. That is what is going on overhead. And I think I've got myself on a view I wasn't expecting to be on here. Let's try that again. Ta-dow! There you go. There is a star chart for Lehigh Valley. That's what's going on overhead Pennsylvania. And once again, check it out. Here's a great example of the North Pole. So here's the Big Dipper. If you draw a line from these two stars, you will find yourself at Polaris. So there is Polaris, the bright star that the Big Dipper points to. Great example of that. Big Dipper, Polaris. And let's move on to a solar system forecast. This is where things are today. Happy new moon coming tomorrow. Actually, tonight will be the new moon. That's where things will be in 1 week on the 19th of December. My, how the year has flown past. Today's astronomy photo of the day is this great auroral imagery as well as imagery of the galaxy. You can see the Milky Way galaxy there. And this image is from Norway. apod.nasa.gov, by the way, if you want to create your own desktop image by saving that astronomy photo of the day, apod.nasa.gov. And let's move on to coronal mass ejections. And you'll see this comet diving in and then vaporizing. This comet faced the end of its days as it rolled in there to the closest star, and you'll see it. Those are frames from yesterday, and early this morning, that comet was gone, but not forgotten. So that's what's been going on. 71 frames from today. Here come some more images. Great view of that comet there. A rogue comet. Here's a little closer view for you. Wait for it. And here it comes. That comet has disintegrated and vaporized out of existence. Moving along to Stereo A. Stereo A shows a good view of that comet as well. It's located right about there. And there it goes. And let's wait for the difference imagery to catch up here. So we've got the raw coronagraph on the left, a little bit ahead of the darn it. Let's try this again. There you go. Great view of the comet in raw coronagraph on the left and difference imagery on the right. This segment brought to you by Smash Staff, who once again said, "Shut up that mutt." Shut up that mutt. This message brought to you by Smash Staff. As she's trying to emulate movie villains. And shut up that mutt is one of the best movie villain lines of all time. Anybody who refers to a dog as a mutt in a movie has got to be a bad guy. Anyway, here's a 24-hour video featuring SDO, along with some great imagery of that comet. So let's get a little closer since we've got spectacular views here. And yes, bring on the comments where people say the comet's electric and everything's electric and space is electric and stars are electric and electric. I would ask you this: if you think everything's electric, what about the insulation on a wire or a styrofoam cup or the tires on your car? Are those electric? Just saying, folks. We wouldn't need the term electric if everything were electric. Anyway, great view there of all of that stuff going on. And here's a close-up of the closest star. Just 193 angstroms by itself. And I do think it is time to get to filaments. Filaments, filaments, filaments. Wherefore art thou, filaments? Because of magnetic fields suspending them and defying gravity. There are some. Here's the Vladimir Putin filament. Here is the Lukashenko filament. The rest of these are not named, and there are quite a lot of plasma filaments, especially in the southeast. But some around the north as well. There is a grayscale imagery also. So quite a lot of filaments. Some of them are quite massive indeed. Tens of thousands of kilometers in length. And before we get to bonus features, here are the past about 3 hours from the GOES 18 SUVI. Again, some plasma reorientation, perhaps CMEs happening down here. Indeed, there was a CME down there, a coronal mass ejection. And let's get to bonus features. First, satellite charging hazards. We have some surface charging here over the Middle East, the Western Indian Ocean in the Middle East, East Africa. Surface charging hazards occurring there. GOES electron flux here cratered, which is a feature typically of geomagnetic unrest conditions. That's what's going on there. A little bit of a decline in the GOES electron flux. So that's sort of expected. CME impacts do cause that. It's an erroneous reading. There is the 1-year graph of the electron flux reported by Solon.info. And there's the forecast model. The next update will be quite a bit lower than the forecast. Green boxes depict the forecast. Yellow diamonds depict the observation. We'll also show the F layer of the ionosphere, the layer where it's measured. Now keep in mind the GOES 16 and the GOES 18 aren't down here at 300 kilometers. They're about 24,000 miles of altitude, so they're way above that. They use radiography to measure the electron flux down here at the F layer. So the refraction of those radio signals are what determine the electron flux. Here is the ionosphere's vibrational frequency. So this is the layer where the electron flux is measured. Now we're not showing the electron flux, we're showing literally the vibrational frequency of the ionosphere itself. It's very diffuse gas, and this is how it's shaken. If that's all Greek to you, don't worry. Here's the anomaly from the 30-day median in megahertz. And we will see more red on here than we would if we hadn't seen some geomagnetic unrest, but no major geomagnetic storms have been happening. So pretty chill conditions here, just a minor CME impact. Here's the latest image, 2300 universal time for the ionogram, 2300 universal time on the anomalygram. And by the way, if you want to name solar filaments, join us over on Twitter. Thanks to our new followers over there on Twitter, x.com/smashomash. Here's the WHAM, the whole atmosphere model. Last Christmas, we didn't show this, but now we do, so you don't get pissed. This year, to prevent you from coming here and clotheslining me, I'll become a pro wrestler. And anyway, that's what's going on. And that's the current scenario for the ionosphere. The Global Ionosphere Nowcast. total electron content, and maximum usable radio frequency. We'll also show total electron content, which is free electrons in about this range, about 12,500 miles of altitude, which is about the altitude of your GPS satellite. There is total electron content. These are the most likely places to see errors in your GPS. We'll close out space weather with the latest. High-res imagery of the closest star. Here's this new sunspot. It is so far only an alpha-class sunspot, so not likely to produce large flares. And the likelihood of seeing large flares is kind of low. The most interesting region right now is this area right here. That sunspot is now the most likely place to see a large flare. It is the most magnetically complex sunspot group. It is the sunspot group that has the best magnetic shear profile to produce large solar flares. Next, let's take a look at meteorology, because it's time for the meteorology segment. We bring the Earth weather and the space weather together into one. So as we get closer and closer to the Earth weather, here is a massive anticyclone in the southern Pacific Ocean. Perfect example there of the counterclockwise rotation that you get in the southern hemisphere from a high pressure zone, known as an anticyclone. They go clockwise in the northern hemisphere, but in the south, counterclockwise. Just like low pressure systems go clockwise in the southern hemisphere, like this one right here. Perfect example of that. Low pressure systems suck, and high pressure systems blow. That's why high pressures spiral outward and low pressures spiral inward, pulling air toward them. Anyway, there's the pressure profile of the planet. There is the Southern Ocean. There is the Arctic Ocean. And let's get to the winds of planet Earth. There are the winds of the east side. There are the jet streams of the east side. And let's pause for station identification. You've reached the Smash News Network. Least busted name in news. These are the jet streams of the central world. These are the surface winds. Surface winds of the west. And these are the jet streams. Clouds and fog are next. Clouds emit radiation. There it is. Infrared radiation, 3.9 micrometers, is the wavelength. And here is a little slice of western South America. So we saw some cool cloud features there, so we figured we'd show that close up. There you can see a great example of a counterclockwise rotating high pressure zone in that area as well. You can see that counterclockwise rotation there. Some atmospheric mixture happening there over the western portion of the South American continent. And next is our pressure map. So here's what's going on down there with pressure. A great example of a high and a low right next to each other. Next, our weather.gov map. Weather.gov is where to go if you've got locations lit. If you're in the lit location, weather.gov is where to get your weather warnings. We do have some winter storm warnings there. Again, weather.gov is the National Weather Service homepage. And next, we've got some forecasts for you. Here come the 72-hour GFS forecasts. First for pressure and precipitation. Next for total accumulated precipitation. Finally, for positive snow depth change in inches. The same model, GFS 72 hour. And heaviest snows will be coming to New Mexico and Colorado. Despite all of the putrid hot air coming out of that state, it's still going to get blanketed with even more snow. How you like them apples? Is it a coincidence? Pretty much. Pretty much. The hot air has nothing to do with the weather forecast because the hot air is pretty weak. That Coloradan hot air. What a mess. Anyway, here's lightning. And no terrestrial strikes recently in the U.S. And that depicts the last approximately 1 hour. So that is courtesy of lightningmaps.org. Lightningmaps.org is where to get your real-time lightning map. Right now, pretty low amount of lightning here. Look at that. Only 0.2 of a strike per minute. That's very slow. Lightning is quite calm here on a planetary scale. We'll close out the video with U.S. weather. There are the full 50 states. Here are the lower 48. That's Doppler. Here are clouds and fog. And here is water vapor. When your Doppler's unclear, use the water vapor. Here's the recap. Doppler radar for the lower 48. Clouds and fog for as many states. And water vapor. It shows the dry air, it shows the moist air, and now I'm showing me climbing back into the bunker. Because, pardon the biting sarcasm, I'm so spooked of space. Oh no, the only thing spookier than space is the galaxy. Oh noes. So I've got to head back to the bunker before the spooky, spooky space comes to get me. Ta-ta. In the meantime, may that solar wind be at your back. I'm going back to the bunker again. I've got to hide in there to prevent.